Right. Today we are going to discuss about the correlation. What do we mean by a correlation? Guys, correlation means by the name itself, it is clearly making us to understand, identifying relationship between the variables. So finding the relationship between the two variables. So what type of variables are there? Quantitative or qualitative? Right or wrong? Huh? What types of variables are there? Quantitative or qualitative? So basically, this correlation is a technique, okay, which is used to determine the degree of two variables, how much they are related and all. Hmm? Okay. So guys, let me tell you, there are two ways of identifying this correlation. One is understanding through a graphical method, and number two is a mathematical method. In graphical method, we will go ahead with the scatter plot. Okay. In graphical method, we will go ahead with the scatter plot. And whereas in the mathematical method, we do have a two types or two methods. We have a many methods actually, out of which these two methods are very important or which are widely used. They are Carl Pearson's and Spearman ranking model. Okay, so now let us see understanding about the correlation. So this is how a correlation scatter diagram looks like. Whatever the variables holding the values, okay, we need to plot them as something just like a coordinates. Okay, these two quantitative variables will hold the different values, and these variables can be called as two different types, like independent variable and a dependent variable. Understand, all of you? Independent variable and dependent variable. So these points are not joined directly however we want. Example. Here we do have the data which is quite related, like weight and systolic blood pressure. Weight and systolic blood pressure. So if you can take a look at this part, scatter diagram of the weight and the systolic blood pressure represents something like this. How does this mean? The points, how they plotted, we can definitely resemble that a linear regression line can be drawn in order to have a perfect correlation between those two variables. So here, how could we understand a positive relationship or a negative relationship or a no relationship from this pattern of the data? It is clearly understood in this pattern, the points moving ahead towards the positive end, and the way the direction of the points are looking in an inclined way of towards the positive direction or positive coordinates. So if you can take a look at this one, number of hours spent studying by the student and final grade in the course. How is this looking? Is this in the production, positive coordinates or not? It's in the positive coordinates. Let us take a look at this one. Age in weeks and height in centimeters. Positive or negative? Guys, is this positive or negative? It's a positive, right? What about this one? Age of the car and reliability. When the age of car is increasing, obviously the reliability of the car will decrease. Hence, it should be considered as a negative relationship. Okay. So can you please take a look at this part? Pulse rate and the weight. Is there a relation between the pulse rate and the weight? Guys, is there a relation? No, there is no relation actually. Okay. Hence, that's why the plotted points are completely scattered. Okay. all those plotted points are completely scattered. Understand? So now, correlation coefficient, how can we measure it? See, we have a Pearson's correlation coefficient. How do we calculate this one? And first of all, how we need to assume the values of or the score of the R. So if the sign is positive and if the sign is negative, there are two different types of relationships. Okay, direct relationship or the indirect relationship. Let us take a look at this part. You can see the -1 to 0 and 0 to 1. -1 to 0 represents the indirect relationship. 0 to 1 represents the direct relationship. Okay. If it is 0, then no relation. No relation between what? There is no relation between the variables. 1 represents the perfect correlation. -1 represents the perfect negative, the indirect perfect correlation. Okay. And here 0.75 less than or equal to or less than equal to 1. Okay. It's going to be a strong correlation. Average correlation 0.25 to 75. Less than 0.25, weak correlation, which is worst. Okay. If it is r equal to 1, it is a perfect correlation. Okay. It is very hard to achieve this perfect correlation. Why? Because the data itself will not allow us to get something like that. How do we compute the simple correlation? It is very 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 much a thing of a mathematical formula. Sigma xy minus sigma x into sigma y divided by n, root square of sigma x square minus sigma x whole square divided by n, into sigma y square minus sigma y whole square divided by n. So here, let us take an example. A sample of 6 children was selected. Data about their age in years and weight in kilograms were recorded as shown in the table. It is required to find the correlation between the age and the weight. So the data is there already. We have the values of each and every variable that we do have it with us. Now let us try to substitute these values in the given formula. So how we are going to, so we need to first calculate the xy, x square, y square, and sum of x square, sum of xy, and sum of y square. Okay, and then if we substitute, I have got something called 0.759. Can you please tell me, is the magnitude of the correlation, otherwise the way we can call it as a magnitude of relation or the correlation coefficient, is this good, bad, or average? All of you. Yeah, it, it is good actually. Okay, it is good. Now I will show you one more thing. This is a strong direct correlation. If you take another example, this is in between the anxiety and the test scores. By looking at this one, we don't have any relation between the anxiety and why? Because anxiety should not get depend on the test scores, whatever that they want to get in the final examinations. So let us ignore, but with a common sense. Okay, if not, if we need to go ahead with the formulaic stuff, this is the one. This is an indirect correlation. There is a still a relation. Minus 0.94. Is this good or bad? Yes, it is. It is also good actually. That is what I'm saying. Even the negative, you're not required to say that it is bad actually. Okay, but it is indirect correlation. That is what I want to say. Okay, this is indirect correlation coefficient. Why I'm talking about this indirect? Okay, let me show you. Let me go back. See, reliability and age of the car. Which kind of relationship is this? Negative relation. Is this not true? While the age of car is getting increased, reliability should decrease. Negative relationship is not at all wrong, but even though in some cases it will show you such a kind of strong relation, okay, indirect strong relation that we need to consider. Okay, all of you understand this part? Indirect correlation. Huh? Are you good, guys? So now let us understand one more model called Spearman rank model. See what we are lagging in the Carl Pearson's model. We are lagging with the qualitative variables, means categorical variables. Hence, the Spearman ranking model will address this issue. Okay, where this is going to be a non-parametric measure of the correlation, where this correlation coefficient will be computed whenever your both variables are qualitative, or whenever your both variables are qualitative and quantitative. Okay, one is qualitative and another one is quantitative. So in this sense, okay, how do we measure it? When we don't have the values, when we have the actual names, how can we calculate this one? Here it comes into the picture that we can calculate this one still by ranking the all the variables, by ranking all the variables. Okay, all of you understand this one, all of you? So we need to rank the variables values from 1 to n. Okay, whether you want to come from the top or down, that's your issue. That's your wish. That's your wish. However you want, you can do it. Okay. Now let us take a look at this one. This is the formula that we are going to apply, which is a DI refers to the difference. Okay, difference between the ranks. Okay, and then how many number, how many number of items are there will be represented with the n, and hence RS represents the Spearman rank model of the correlation coefficient. So now let us see an example. Here we do have the income based upon the level of education. So as a part of this, what I'm going to do, I need to rank them, right? Okay, I have the one set of the quantitative variables, variable data, and one set of the numerical variable data. Okay, if you take a look at the categorical variable data, okay, you can strongly see that what is the top one here, guys? University, right or wrong? What is the next top here? University again. So we have two universities which is representing over here. Instead of giving 1 and 2, I'm going to give 1.5, average of 1 and 2, 1.5. So 1 and 2 is completed. Next it is 3. Okay. So 3 needs to be given for the secondary. We have the two secondaries, 3 and 4. Take an average, 3.5. I'm going to give the 3.5 for both of them. And next one should be 5. So preparatory is given as 5, primary is given as 6, and illiterate has given as 7. In the same way, I have given the rank from top to bottom on the y column also. What is the top one here? 60. Next 50, 1, 2. Something like that. You have to provide the 3, which is 25, 4, which is 15, 5.5, 5.5, which is 10. Okay, and 7 directly. Why? Because 5 and 6 are captured and it was taken as an average. And you have to take the difference between this rank X and rank Y. Okay, and those differences should be whole squared in order to avoid the negative figures, and you will get the 64 as a answer here. And finally it is zero point 0.1. See, R value is minus 0.1. Is this a strong relation or weak relation or average? Is it strong? Huh? How it is strong, sir? 6 represents, see, it is there in the formula itself. 6 sigma di whole square. 1 minus 6 sigma di whole square divided by n into n square minus 1. Yeah, it's a constant. It is constant. So take a look at this one, guys. This is an indirect weak correlation between the level of, see, minus 0.1. 0.1 is less than 0.25, man. Whenever the 0.1 is less than 0.25, it is definitely a weak correlation. But whenever it is a minus negative signature, then you can consider it as an indirect weak correlation between the level of education and the income. All of you understand this? Now I'm going to give you an exercise. Take a look at this part. So you can see the plot A, plot B, plot C, plot D. Okay. Can you please recognize there are some values? R is equal to minus 0.5, R is equal to minus 0.9, R is equal to 0.49, R is equal to 0.93. Can you identify the A, B, C, D values for each and every correlation coefficient value? The very first one is minus 0.95. Minus 0.95 represents negative but strong correlation. What are all the coordinates that they are in the negative signature? Plot A and plot B. Can you please tell me in between plot A and plot B, which could be the minus 0.95 and which could be the minus 0.9 by taking a look at? Exactly, the plot A represents clearly minus 0.95. Okay, can I make the minus 0.9 as plot D? Right. Okay. Now, can you please tell me again? I do have something called R is equal to 0.49. What is the answer? No, it is not C. Yeah, exactly. It is C. I'm sorry. Myself, I'm sorry. See, R is equal to 0.49 represents plot C. Okay. R is equal to 0.93 represents plot B. Okay. So the answer is A D C B. A D C B. Okay. All of you? All of you understand this? So guys, I just wanted to tell you this is what about the correlation coefficient. With the help of this correlation coefficient, we will always try to identify the relation between the two variables. Understand all of you? Huh? Yeah. So we need to see even more in the regression part. Okay. We have a very simple simple regression, uh, linear models. Before that, I need to give you some mathematical approach, understanding about how well that it will work and all stuff. I will take it up in the tomorrow session. So guys, I just wanted to ask you one question. um, Actually, one second, let me tell you. When we are meeting tomorrow, okay, so mostly I think that I do have some of the you know things to um, work out well. And as a part of it, can we have one more session in the evening 8 to 9, all of you, just for 2 days? Tomorrow and day after tomorrow, can we have the session at in the evening 8 to 9? Narayana is okay, Arun is okay, Ram Dinesh is okay. Okay, 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 okay. Thank you all. Then I'm going to ask the admin only for tomorrow and day after tomorrow. I will request them to keep the session in the evening 8 to 9. Okay, rather than in the morning 8 to 9. Okay, let us meet in the evening 8 to 9 from tomorrow, just for 2 days. Again on Friday, I will take it in the morning itself. Okay. Thanks. Thank. Thank you all. Who is this that Ashok, you can't join? Okay, so let us do one thing, Ashok. What I will do, I will take it why? Because those two sessions which I'm going to take it up, please go through the video. I will take you separately. Okay, I will schedule one session for you. Okay, why? Because this schedule was changed by me myself. Okay, I'm requesting you people. Okay, I will take you one for you. Okay, if you have any questions, if you let me know. Okay, in the same session or in some other session in the morning. Okay, I will separate. I mean, once after the session is completed, I will spend some time for with you, and I will explain you. No issues. Okay, guys, I will see you all tomorrow. Bye.